Building a car engine is like orchestrating a symphony of power. It all starts with a vision, a blueprint that dictates every curve and contour of this mechanical marvel. Engineers, the composers of this automotive concerto, meticulously map out the engine's destiny. They decide what type of engine it will be, like a powerful V8 or an efficient four-cylinder. They determine its size or displacement, which influences how much power it can unleash. The selection of materials is paramount. It's a delicate balance of strength, weight, and resilience against extreme temperatures. Aluminum, with its lightweight nature, is often favored for the engine block, the heart of the engine. Cast iron, known for its durability, is typically chosen for the crankshaft, the backbone of the engine, but the design phase is not just about physical form, it's also about simulating the engine's soul. Sophisticated computer programs breathe life into the digital blueprints. They predict how the engine will perform under various conditions, from a gentle cruise to a full-throttle roar. This virtual proving ground helps engineers identify any potential flaws and refine the design before a single piece of metal is cast. It's like fine-tuning an instrument before the grand performance. The engine block, the foundation of the engine, begins its life in a fiery inferno. Molten metal heated to temperatures that could melt steel is poured into carefully crafted molds. As the metal cools and solidifies, it takes on the intricate shape of the engine block. This process, known as casting, is like shaping a raw block of clay into a work of art. Once cooled, the rough casting is far from finished. It's a diamond in the rough, requiring meticulous refinement. This is where the precision of machining comes into play. Giant computer-controlled machines, guided by the digital blueprints, carve away excess material with pinpoint accuracy. They bore out the cylinders, the chambers where combustion takes place. They carve channels for oil, the lifeblood of the engine, to flow through, and they create mounting points for the various components that will transform this block of metal into a beating heart of power. The crankshaft is the unsung hero of the engine, transforming the reciprocating motion of the pistons into the rotational force that drives the wheels. Its creation is a testament to the power of forging, a process that dates back centuries. Imagine a blacksmith hammering a piece of red-hot metal, shaping it with each blow. Forging works in a similar way, but on a much larger scale. A large piece of steel, heated to extreme temperatures, is placed into a forging press. This powerful machine, capable of exerting incredible force, hammers the metal into the rough shape of a crankshaft. The intense pressure and heat not only shape the metal, but also align its internal grain structure, making it incredibly strong and resistant to the immense stresses it will endure during operation. The cylinder head sits atop the engine block, sealing the cylinders and housing a complex dance of valves, springs, and combustion. Like the engine block, it often begins its life as molten aluminum, poured into a mold and left to cool. But the cylinder head's journey is far from over. Machining transforms the raw casting into a precision component. Valve seats, where the valves will rest, are carefully cut to ensure a perfect seal. Coolant passages, responsible for regulating the engine's temperature, are drilled with precision, and the combustion chambers, where fuel and air mix to create the engine's power, are honed to exact specifications. It's a symphony of precision engineering, ensuring that every component works in perfect harmony. Section 5. The heartbeat of the engine. Pistons and connecting rods. The pistons are the engine's drummers, moving up and down within the cylinders, driven by the force of combustion. Connecting rods, like the drummer's arms, link the pistons to the crankshaft, translating their linear motion into the rotational force that powers the vehicle. Pistons are typically forged from aluminum, their lightweight nature reducing the engine's overall mass and allowing it to rev more freely. Connecting rods, often forged from steel, must be incredibly strong to withstand the immense forces generated during engine operation. Both components undergo extensive machining to ensure they meet exacting tolerances. The slightest imperfection can affect engine performance and longevity. Section 6. Putting the puzzle together, assembling an engine. With the key components crafted, the process of assembling the engine begins. It's a carefully choreographed ballet of man and machine, where each part must be installed in the correct sequence and to exacting specifications. The engine block, thoroughly cleaned and inspected, serves as the stage for this mechanical ballet. The crankshaft is carefully lowered into its bearings, and the pistons, connected to their respective connecting rods, are inserted into the cylinders. The cylinder head, with its valves and springs installed, is then bolted onto the engine block, creating a sealed environment for combustion to occur. Every bolt is torqued to a specific tightness, ensuring that the components are held together securely, but not overly stressed. Lubricants are applied at critical points to reduce friction and wear. It's a symphony of precision, where even the smallest detail can affect the engine's performance and longevity. Section 7. Ensuring excellence, quality control and engine testing. Before an engine can leave the factory, it must prove its worth. Rigorous testing procedures, like a series of demanding exams, are carried out to ensure that every engine meets the highest standards of quality and performance. Visual inspections are the first line of defense, with trained eyes scanning for any imperfections or assembly errors. Then comes the compression test, which measures the ability of the cylinders to hold pressure, a critical factor in efficient combustion. If an engine fails to meet the required compression, it's sent back for further diagnosis and repair. The engine is then connected to a dynamometer, or dyno for short. This sophisticated piece of equipment simulates real-world driving conditions, allowing engineers to measure the engine's power output, torque, and fuel consumption. It's the engine's final exam, and only those that pass with flying colors earn the right to power a vehicle. Section 8. Mating of machine and motor engine integration and final assembly. The engine, having proven its mettle, is now ready to be united with its mechanical soulmate, the vehicle it will propel. This stage of the process involves carefully lowering the engine into the vehicle's engine bay, a task that requires precision and a steady hand. Once in place, the engine is connected to the transmission, the system that transfers the engine's power to the wheels. The exhaust system, responsible for channeling away exhaust gases, is bolted on, followed by the cooling system, which keeps the engine from overheating. The intricate web of wiring that carries electrical signals to and from the engine is connected, bringing the engine to life. Section 9. From factory floor to open road, final testing and validation. The final stage of the journey involves a series of real-world tests designed to ensure that the engine, now an integral part of the vehicle, performs flawlessly under all driving conditions. Test drivers put the vehicle through its paces, driving it on a variety of roads and at different speeds, listening for any unusual noises and monitoring its performance. This final evaluation is the ultimate test of the engine's capabilities. It's the culmination of countless hours of design, engineering, manufacturing, and testing. Only when the vehicle has passed this final hurdle is it deemed ready to be released into the wild, where it will carry its passengers safely and reliably to their destinations.